Okay, so today we're going to do the second half of this foldable um, about solving systems of equations algebraically, and that's the elimination method down here, section 4.3 in our Envision textbook. So one of the ways that we learned to solve systems algebraically is with the substitution method. Now we're going to use this elimination method, and this method always makes me kind of think about making common denominators with fractions so that you can add or subtract them, except we're going to be trying to do that process with equations so that we can add or subtract them. So we're going to start by making sure our equations are in standard form. We want our equations to be in standard form in order to use this method. And remember, standard form looks like this: ax plus by equals c. So you have x and y on the same side of the equation. Then we want to add or subtract the two equations to eliminate, right? This is called the elimination method, to eliminate either x or y. Here's where the common denominator thought comes in. You may need to multiply one or both equations to get the same coefficients on the variable, okay? So in this first example, we aren't going to need to do that because I already have matching matching coefficients, and those are the coefficients of y. Both of these equations, the coefficient of y is 3. So I don't need to multiply the equations by anything. Instead, I can just go ahead and subtract one equation from another. And I'm choosing to subtract and not add because both of these coefficients are positive, right? So if I want to eliminate the term with y, I should subtract 3y from 3y because that leaves me with 0y. It eliminates that term, okay? So 5x minus 8x is negative 3x. 3y minus 3y is 0y. That eliminates that term. And negative 19 minus negative 25 is the same as negative 19 plus 25, which would be positive 6. Okay, now this is pretty easy to solve for x. All I have to do is divide by the coefficient of x, negative 3, and I can see that x equals negative 2. That was nice and quick. And I also need to substitute that value into either equation to solve for the other variable. So remember, I'm not done solving a system until I have both the values of x and y in the ordered pair. It doesn't matter which equation you choose, I'll just do the first one. So the first one says 5x plus 3y equals negative 19. Now I know the value of x is equal to negative 2, so I'm replacing x with negative 2. And now I can solve for my missing y value. So this equals negative 10. I need to add 10 to cancel out the constant. Negative 19 plus 10 is negative 9. And then I'm going to divide by the coefficient 3 to get y equals negative 3. And now I just need to write my solution as an ordered pair. So my solution to this problem is negative 2, comma, negative 3. Okay, that's the elimination method. Let's go ahead and do that again. So make sure both equations are in standard form, which they are. Then I need to make sure that two of the coefficients match, okay, the numbers match. So 5 doesn't match 9 and 3 doesn't match 4. So now is where I'm going to have to multiply one or both of my equations to get the coefficients to be the same number. I'll go with the smaller numbers, so we'll go with eliminating y again first. And I think about what can I make these two numbers into. This is where I think about the lowest common denominator, right, or the least common multiple, which would be 12. And to make the 3 into 12, I would multiply this top equation by 4. And to make the 4 into 12, I would multiply this bottom equation by 3. And I can't just multiply the middle term, the term with y, by these numbers. I have to multiply the entire equation by these numbers to make them equal versions of the equation. So I'm going to do 4 times 5x, which is 20x, 4 times positive 3y, which is positive 12y, and 4 times 52, which is 208. And then I'm going to do 3 times 9x, which is 27x, 3 times negative 4y, which is negative 12y, and 3 times 56, which is 168. Okay, so now my terms with y are both 12. But that being said, this time 1 is positive 12 and 1 is negative 12, as opposed to over here where they were both positive. So now, instead of subtracting the equations from each other, I'm going to add the equations to one another, because I know when I add the opposite, that equals 0, right? When I add the opposite, those cancel out to equal 0, which is what I want. I want these to equal 0 so that I eliminate one of the variables. Okay, so 20x plus 27x is 47x. 12 plus negative 12 is 0. And 208 plus 168 is 376. And now I can divide both sides by 47. And I'm left with x equals 8. Okay, that's part of my answer. Now I need to substitute that value into one of these equations to find my y value. It doesn't matter which. You could use one of these two, or these are actually the same equations as well. But I'm going to go ahead and just do the first one again. That's usually the way that I proceed. So 5x plus 3y equals 52. Where x is equal to 8. Five times 8 leaves me with 40. Now I subtract 40 from either side. I'm left with 3y equals 12. So when I divide, I'm left with y equals 4. And now I can write my solution as 8, 4. Sorry. Okay, and remember, these are the points where these lines would intersect one another on a graph. All right, last one. Both of these equations are in standard form, and actually both of the coefficients of x and y match. Okay, so I don't have to do any multiplication of these equations. I can just go ahead and decide whether I'm going to add them to one another or subtract. The signs are different, So when the signs are different, that's when we add the equations. When the signs are the same, that's when we subtract the equations. That might even be something that you write in your margin on your notes. When the signs are different, that's when we add the equations. When the signs are the same, that's when we subtract the equations. Okay, so 5x plus negative 5x cancels out to be 0. 6y plus negative 6y cancels out to be 0. And 45 plus 38 equals 83. And 0 does not equal 83. That's a false statement. So this means that there is no solution to this system. These would be parallel lines.